Okay, everyone, here we go. Solve by completing the square, part A. Our quadratic equation is x squared plus 8x equals 9. Here's how we're going to go about it. We're going to say, you know what, that left side, we're going to complete the square. What does that mean? We're going to do this idea of filling in the blank. Complete the square here. I'm going to think of it this way. For the x squared plus 8x, I want it to look like x squared plus 8x plus something. And I fill in that blank the same way we did those last examples. So, what should go in the blank? And the pattern is take that number, right? Divide it in half and square it. Well, 8 divided by 2 is 4. 4 squared, 16. And there we go. We've completed the square on the left side. Now at this point, we should pause and say, hey, okay, this is good. I completed the square there. We'll see what happens next. But wait a second. If I just up and add 16 to the left side, don't I have to do it to the right side as well to keep it all balanced? So if I up and add 16 to the left, I also need to add that same number to the right side. Then I've done the same thing to both sides. And I made notes of that. Here I left room for it. So this came from 8 divided by 2 squared. And this, we must also add to the right side. If we add 16 to the left, we got to add 16 to the right. Okay. At this step, we have completed the square by adding that 16 based on the 8, and then we copy that plus 16 to the other. How is that helpful to solve this equation? Okay, so what I see on the left, I'm going to replace this with what it would be equal in parentheses squared. So if I've got x squared plus 8x plus 16, that can be replaced with, looks like I'm showing you too much of the problem here at once. Let's cover that up. I'm going to replace this with x plus 4 squared. What it would have been equal to back, right? So that's the quantity, x plus 4, yeah. So I'm rewriting, after I complete the square, then I rewrite it in its factored form, really. At the same time, let's take the 9 plus 16. And we're just simplifying there. 9 plus 16 is 25. Okay. Whoa, got a little breeze happening. So where do we go from here? Once we have this line, you think, oh, wait a second. This is the sort of situation we saw back in 9.1. We can take the square root of both sides. And I haven't shown it, but if we take the square root of the left, it will cancel this. If we take the square root of the right side, we get 5. Don't forget we need the plus or minus there. So square root 25 with the plus or minus 5. And because we're not done at that point, we then need to write the two statements, x plus 4 equals 5 and x plus 4 equals negative 5 separately. And the last step, subtract the 4 in both cases and we arrive at our two answers, x equals 1 and x equals -9. So the idea behind completing the square is it puts you in a position where you can then just take a square root of both sides, and you're just a couple of steps away using the ideas from the square root property. So just again, like there's a lot going on here. Completing the square is a very technical process. We've got to recognize, what number do we need to add here? And we got to, okay, it's half of that number squared, right? Then we got to make sure we do it to the other side. Then we've got to rewrite this correctly and simplify there, and then we can go for it. A lot happening. And I'll tell you, there's a lot going on in this problem, and this is as easy as they get. This is about as straightforward and as simple as completing the square as there is. Bring your questions when we meet on Monday night after spring break. Okay, let's look at some more. I've actually got two more of these. They get progressively more difficult. How about this? Part B, n squared minus 3n plus 1 equals 0. There's actually a couple things going on here. So you notice we don't have the n squared minus 3n by itself and the number on the other side. The plus 1 is on the left. First thing we need to do is isolate both the n squared and the minus 3n. So we're going to subtract the 1 here at this first step, giving us that. Why do we need to subtract the 1 to get started? Because we're going to complete the square here. The next line would be this. N squared minus 3n plus what? What should we add to form a perfect square trinomial on that left side? And I think I might have given it away. I don't know if you saw. Hey, we take half of that number and square it, right? 3 over 2 squared, which is 9 over 4. And we got the fraction here because we had an odd number. But, it is what it is. It's the same pattern. Half of the number squared. At that same time, same step, we'll notice, hey, we just up and added 9 over 4 to the left. We need to do the same thing on the right to balance that out. If we add it to the left, we got to add it to the right. Okay. What comes next? We're going to replace this left side with the parentheses squared. How would that look? Well, it's going to begin with n. Since this is a minus, we're going to have a minus. We know it's going to be squared. What number is going to go here? And well, it's the pattern, you take the number before it got squared. So 3 over 2 will be our new left side. So that whole thing is going to turn into this, the squared version, the factored version, if you will. Okay. Oh, a lot is going on. So I'm trying not to go too fast. But slow it down, stop it, of course, at any time. In the same step, let's simplify here. Turns out negative 1 plus 9 over 4 is 5 over 4. And, if you wanted to see that out, of course, you could do it in a calculator and convert your answer to a fraction. Or you could think of negative 1 as negative 4 over 4 plus 9 over 4. Well, that would give you positive 5 over 4, right? Okay. At this point, we have completed the square successfully. So now we're in a position where we can simply take the square root of both sides to cancel that. So let's go for it. Taking the square root of the left, well, it's just going to cancel out, and we'll be left with n minus 3 over 2. And here's the square root of the right side, remembering that we need the plus or minus on the outside there. We're going to split this into its two parts, but first, hey, we can notice when you take the square root of a fraction, you can take the square root of the numerator and denominator separately, right? That was one of the rules or properties of radicals, that you can take these square roots. And we like that because we can do the square root of 4 as 2. Also notice I went ahead here and I just chose to do it at this step, but I took that plus or minus and I actually just applied it to the numerator instead of out front of the fraction. I could have left it out front, but I could move it to the numerator. No, I mean, there's no difference. Okay, here's what I'd like to do. Let's see, I have it written a little bit differently below my page. I would like to rewrite it as the 2. Let's do that on my page here. Let's write it as n minus 3 over 2 equals the positive version, and n minus 3 over 2 equals the negative version. And where could we go from there? Well, we can add 3 over 2, right, in both cases. Like so. And this would be good. This would work for our two answers. Although you do notice that the denominators are 2. So I could even put that together as one fraction this way. And same thing over here. They've already got a common denominator. And I could answer just like that. Or you may notice, hey, the only difference here is the plus there and the minus there. Could we simply answer as 3 plus or minus square root 5 over 2? And yes, you certainly can. So I prefer this presentation to the way I was going to show you guys originally. So I'm just going to leave it at that. There are still two answers. They're honestly pretty ugly answers, right? We've got these fractions and we've got, these radicals involved in the fractions. But, it is what it is, and that's the nature of these sort of problems. especially with completing the square. So that was a big one. We're going to stop this video here. I have one more example for you in the next video.